In the previous class, we have discussed about what is a photodiode. Photo, when the term we hear the photo, it is indicating that photon energy, photons, light energy is in the form of the photons. As we already discussed, Newton said light is having the particle nature. Then Christian Huygens came and said light is having the wave nature. Then Maxwell came and said no need to fight. Light is having both particle nature and wave nature. That was the statement given by Maxwell. So this light, when we are taking, because light is nothing but a group of photons, we are calling this transistor as a phototransistor, as this transistor operates with the light like photodiode. The principle of operation is same as photodiode. But because this is a transistor, it is having three terminals, emitter, base and collector. Whereas in the photodiode we have only two terminals. One is anode and the second one is cathode. Here we have two junctions. One is emitter base junction and the second one is a collector base junction. We are trying to replicate the action of the photodiode in the base collector region. Means we want to use this base collector region as photodiode. Our intention is, this is a transistor, but we already knew the operation of photodiode. In the lines of the photodiode, when we are learning, we are saying particularly this base and collector region we are using like a photodiode. So this region we are using like a photodiode. In the photodiode we discussed this depletion region. In this depletion region, because there are no free charge carriers are there, only immobile ions are there, this acts like an insulator. That's what the normal depletion region of any PN junction diode. But photodiode particularly, we have made this depletion region exposed to the light. By taking that light energy with the lens, this light energy excites the electrons in the covalent bonds. By taking the energy in the form of the light, these electrons, they go from the covalent bonds and they come out. So this is the normal silicon structure. When we are representing the positive ions, we are saying phosphorus is replacing the silicon and it is donating one electron. That's why phosphorus is getting a positive charge. Only these positively charged ions are there on the N side. When the light is incidenting, the electron in this covalent bond, it gets energy and it comes out. Because of what factor the electron came out? Because of the light energy. We discussed previously the electrons are coming out because of the thermal energy. But in the photodiode we discussed these electrons can come out with the light energy also. Whatever may be the form of the energy, if you give energy, electron will come out. When I am giving sound energy, you may call that diode as some sound transistor or sound diode, audio transistor or audio diode. That is not at all there now. But whatever the form of the energy you are giving, if you give some energy to the electron in the covalent bond, the electron will get excited and it will come out because it got the extra energy compared to the electron which has to be there in the last orbit. So here hole is forming. Because of this incident light, the electron hole pairs are being formed. These electron hole pairs, the electrons, because this side the negatively charged region is there, like a negative terminal of the battery, the electrons will be repelled to the N region. And similarly, The formed holes, even though the hole is an imaginary particle, even though the movement of hole is an imaginary concept, we are saying the electron is coming here, the hole, this electron is replacing this one, then we are saying the hole is moving from here to here. See, the hole is never moving because it is it is an imaginary particle. That particle itself, it is not at all existing, but still it is appearing like the hole is moving from here to here when the bounded electron in the covalent bond is moving from here to here. So whenever we are saying the holes are moving, in reality the bounded electrons are moving from one covalent bond to another covalent bond. So the current is due to two factors. One is electron current, second one is hole current. Electron current is due to the free electrons, and the hole current is due to the movement of the bounded electrons from one covalent bond to another covalent bond. In these two factors, the current is due to the electrons only. But some electrons are free electrons and some electrons are moving from one covalent bond to another covalent bond. That concept we are representing as one hole is moving from this covalent bond to another covalent bond. But you should always remember, hole itself, it is an imaginary particle. Itself, it is not at all existing. That's why whenever I am saying holes are moving from here to here, you have to think it is an imaginary concept. For our convenience, we are saying holes are moving to this side. Sir, why holes are moving to this side only? Holes are moving to this side because here the positively charged region is there. It behaves like a positive terminal of the battery. And here the negatively charged region is there. It behaves like a negative terminal of the battery. Electron-hole pairs are formed in the depletion region. The electrons are going towards the n-type semiconductor because here the negatively charged terminal of the battery is there. It will not allow the electron to come to this side. So the electrons have to move towards the n region only. And the holes are moving towards the p region. Because this side, the positive terminal of the battery is there. They are repelling the holes. The positive terminal of the battery repelling the holes to come to this side. So that's why the holes are moving to this side. Finally, in the depletion region, previously which one we called as an insulator, some electrons and hole pairs are formed. Free charge carriers are formed. These free charge carriers are moving. That is giving the current. So this current we have represented with the equations. So that current is due to the light only. That's why we are calling this as a phototransistor. When there is no light, when it is connected in the reverse bias, the current is due to minority charge carriers only. This side the minority charge carriers are holes, and this side the minority charge carriers are electrons. When the minority charge carriers holes are moving to this side and the minority charge carriers electrons are moving to this side, a small current is observed. But when you are giving the light, a huge amount of current is observed. When you are giving the more amount of the light, more output will be observed. For the same amount of the light, if you give to the photodiode and phototransistor, the output of the phototransistor is higher than the photodiode. Because phototransistor is acting like photodiode plus an amplifier. So photodiode, if we give the light, it is giving some output. Compared to that output, for the same light, when we give to the transistor, phototransistor, the output will be higher. So here the photodiode is it is constructed like a normal BJT only, bipolar junction transistor. So it has three terminals, emitter, base and collector, and the regions also like normal BJT only. The doping also done. The emitter is heavily doped, base is lightly doped, and collector is moderately doped. And area of the width also, for collector it is more and base it is less and emitter it is moderate. These concepts are same. In BJT we have two junctions. One is emitter based junction and the second one is collector based junction. We are not touching about the emitter based junction. Our focus is only on the collector based junction. We want to use this collector based junction as a photodiode. So we are using this collector based junction like we have used in the photodiode. That depletion region we are using. This phototransistor we are calling as a light detector. Photodiode is also a light detector because it is detecting the light and it is giving the output. It is taking the light energy and it is converting into the electrical energy. This is the circuit symbol of the phototransistor. We have base, emitter, collector. It is looking like a normal bipolar junction transistor because the arrow of the emitter is the outwards. It is indicating that it is an NPN transistor. But the only difference is here the inward arrow at the collector base junction. It is indicating that light is falling on the depletion region of the collector base junction of this phototransistor. This inward arrows, the incident of the light is being indicated with these inward arrows. The only difference between the normal BJT, normal transistor and the phototransistor is incident of this light. The incident of light we are particularly representing in this collector base junction. Because the incident of light here you can see, here we have drilled a small hole here. Because the light, we are expecting the depletion region should be exposed to the light. And the light should be focused. That's why we are even giving the lens to it. It is the lens. The light should be focused. The focused light is falling on the depletion region. We are not expecting the light to fall on the remaining region. That's why we cover the remaining region in such a way that the remaining region should not be exposed to the light. These concepts we have already discussed in the photodiode. In these three terminals, we have three terminals already discussed, base, emitter and collector like a normal BJT. We use the collector terminal and emitter terminal, but we keep the base terminal open. We are not giving any input to the base terminal. This is the difference between normal BJT and phototransistor. In normal BJT, we will give the input to the base terminal. But here we are consciously, we are not giving any input to the base. We are keeping the base open. So the base terminal is kept open. And this transistor is connected in common emitter configuration because the emitter is common for the input and the output. Here we have not given any particular input. When the light falls, that itself is the input. We don't want any electrical input. What is the input here? Light. That itself it is the input. The input is light, output we are expecting from it. In the characteristics, that's why you can see the output characteristics VCE because it is connected in common emitter configuration and the output current is IC. We are taking the collector current. Finally, the output current we need IC. Here you can see we did not represent with the base current. Like for the normal CE configuration, when we represent the output characteristics, we will represent in such a way that when the base current is changing, how this graph is changing. That's how we represent. But here we are representing in such a way that when there is no light, when there is no light intensity, then H is equal to 0 lux At that time also some current is there. Sir, when there is no light, still current is there. Yes, that current is due to the thermally generated minority carriers. That current is very small. Even though it is looking like I have represented some graph, in this graph the current is more, but in reality this current is very less. That current is due to minority charge carriers only. That current is due to thermally generated charge carriers only. That current is very much less. Now when we are increasing the light, suddenly that current increases. When there is no light, even the IB itself, it is very less. The recombination base current. And IC also it is very less. IB and IC are interdependent. What is the relationship between IC and IB? Here we have given, we will discuss. Relationship is IC is equal to 1 plus beta into ICBO. But generally ICBO we use as a reverse saturation current. This particular ICBO will be given to us with the manufacturer. So we are representing with the ICBO, even though we have connected in the common emitter configuration. We are interested to represent with the ICBO only. 1 plus beta into ICBO. This is the collector current equation we are representing. And this collector current, now we are adding some more factor, that is I lambda. This I lambda is due to the incident light. This current is very small, very small. IC is very much small. Beta is the current amplification factor when the transistor is connected in common emitter configuration. Alpha is the current amplification factor when the transistor is connected in common base configuration, and gamma is the current amplification factor when the transistor is connected in common collector configuration. This already we have discussed. Now you see, because of the light intensity, when the light intensity is increasing, then collector current is increasing. In the absence of the light, the collector current is very much less. In the presence of the light, the collector current is increasing. We can use this principle in the optical communication, because in olden days, there was a coaxial cable. In that coaxial cable, we used to send the signals, electrical signals. But now we are using the optical fiber cables. In the optical fiber cables, we are not sending the electrical signals, but we are sending the information in the form of the light. So we have to convert the electrical signal to light signal at the transmitting end. At the receiving end, we have to convert again the light signal to electrical signal. At that time, we require the photo transistor. Means if you are at the home, your TV is connected to optical fiber because you are receiving the light signal, but your TV will not understand the light signal. It has to be converted to the electrical signal. At that time, we are using this photo transistor. In the light operated switches, we use the photo transistor. In the optical communication, we use the photo transistor. In the optocoupler, which we will discuss as a next topic. So in the optocoupler also, we will use this photo transistor. And in counting of the objects, you see, sometimes you may get doubt. In industries, how they will count? If there is a biscuit packet, exactly these biscuits should be one. If one human being is there to count the biscuits, then it will take much time for him. So some object counting mechanism should be there. When one biscuit is going, it is counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then it is packing. Similarly, water bottles, a case of water bottles. Or whenever you require some counting of objects is required, at that time, simply the object can go through under the photo transistor. This will count that and it will give the counting when it is connected to a processor and controller. And based on that, we can tell how many devices are, or how many biscuits are there, or how many bottles are there. So in the production counting of the objects also, we use this photo transistor. We have discussed Phototransistor is like a normal BJT, but the exceptional phenomenon we have introduced is we are adding the ability to take the light, that is represented with these arrows. So it is a normal BJT plus ability to receive the light, and it is converting that light energy to electrical energy. By taking this light at the depletion region, electron hole pairs are forming. Because of these electron hole pairs, the collector current is being incremented. The more light falls on the collector base junction, the collector current is increasing the more. That's why we have represented when the intensity of the light is increasing, the collector current is increasing the more. This is the phototransistor.